Okay. All right, now we are on mineral exploration. So if we want to increase our supply, uh, how would we do that? Well, we can find more. How do we find more deposits and ores out there? Um, Here's an example of groundwater sampling. This is a gold deposit down here, and groundwater is going to pick up little traces of it, and it's going to flow downstream. And so if we drill these wells, we can sample the water, and if we find little traces of gold, then we can trace that back to where the gold is. There are other geophysical methods used, like gravity, magnetic surveys, electrical property surveys, that we can run these things over the surface and pick up differences in like gravity. Some minerals are more dense or less dense than others, and we can pick others being, your average continental crustal rock, and we can um, tell that there's something there. And depending on how the gravity changes, and by how much, we can kind of guess maybe what it is that's there. Magnetic, if you have something that's magnetic, it's going to be picked up. And then electrical properties, like obviously metal conducts electricity and like silica doesn't. So we can pick that up too. Um, Geochemical survey, that's what this here is. We can do the same thing in soil, and look at, you know, the soil is going to have little pieces of the things in the underlying bedrock, most of the time, unless the soil has been washed downstream, like from a river or something. But if it's soil that has formed from um, like weathering of the bedrock, then we're going to see little traces of that as well. And then we have remote sensing that's helping us look into areas that we usually can't get to. And so remote sensing is pretty much like our satellites. Um, so we're able to go to these like high mountain regions or maybe areas of political conflict that we can't get to, maybe really cold areas, and see what's there. We can take just regular pictures like this is showing, or we can look at different varying wavelengths using things like maybe infrared and natural light. So depending on what we're looking at, or what wavelengths we're using, we can see different things. So this is highlighting. So in some of these, it's highlighting vegetation as red. Other things, it's highlighting limestone in green. So the thing on the surface emits different levels of electromagnetic radiation, and our sensors can pick these things up, and then we can filter the sensor to kind of say, okay, well, just now show me like the infrared and not the visible light, and we can see the differences, and we can get an idea of what's down there. Now we really never certain, we do need to prove what we think we're looking at by boots on the ground, if you will, by going out and actually sampling and making sure that we have the right correlation to what light filtering really is showing. We can also use geologic history and mapping. So if we know how the continents, this is an example of knowing how the continents were laid out in the past. We didn't always know this, so this is kind of new. And then we can easily say, well, okay, well, if we know that this deposit is here on the tip of Africa and the continents were torn apart in the past, then we can probably find that same thing right here in South Africa, or maybe Antarctica, where we can't get to and sample or mine at all right now. And so we can do a lot of that now that we couldn't do, 100 years ago. And as I mentioned, we are getting into uncharted territories like the ocean. Seawater contains a lot of dissolved minerals and many useful elements. And currently, extraction techniques are very energy intensive and expensive, because if you're going down hundreds of feet of water, obviously that's difficult. Even if you want to just put equipment down there, like what do you do? Do you have to go to the ocean floor and build up from the top? Do you try to hold the platform or the boat still, more or less? Which they can do, but that's very, very, you're using a lot of energy to fight the currents to keep that platform still. Um, Using a lot of material to build a platform that connects all the way to the ocean floor. If you're going to have little submarines, again, very expensive for all of this. Um, and of course, we do expect there to be a lot of hydrothermal deposits near the spreading ridges on the seafloor, but currently they're too far and too deep to be economical to go after. There are manganese nodules, which just kind of precipitate out of the ocean water, as it comes into the ocean, as it's washed down from the continents and things, it becomes concentrated, and kind of saturated and precipitates out. And they're kind of widely distributed all over the ocean floor. Um, so that would be a nice source, but then how do you get there? And there's a lot of political and environmental and legal obstacles to be overcome. Nobody wants to go in and mess with the ocean's ecosystem, as well as legal obstacles. And political, like who owns the ocean? Right now, nobody does. And so if you start mining it, then you're giving that country those mineral rights. How do you take care of that? And I think, like we've mentioned, we need to start conserving mineral resources. We're using more and more, and we will run out eventually. So we need to reduce this expansion. You could maybe substitute mineral resources from one for another that might not be so rare. Like a lot of plastics are replacing automobile parts, but then plastics also comes with, I mean, plastics comes from oil, which is not really mined, but very similar to mining. It's still in the ground, and we're getting it out of the ground or extracting it out of the ground. And we can recycle what we already have instead of throwing it away. Here's a chart of the percent of consumption of metals that have been recycled given the years. You can see an overall increase. Um, but not necessarily for everything. And that is it for that. Next, we will go into environmental impacts.